Hello everyone! My name is Pearl Uberu and I am a technical marketing engineer here at Databricks. And today, I'm going to take you through our data warehousing, data analytics, and BI solution here on Databricks called Databricks SQL. Throughout this training, we'll be working with the sample dataset from the TPCH benchmark. We'll have access to tables that describe orders from customers and line item information about these orders. We'll use the Medallion architecture to improve the structure and quality of our data as it flows from each layer, bronze, silver, and gold. We'll then create an AI BI dashboard and use Genie using natural language to give us a summary of the data. And then we'll set up an alert to notify us if the number of customers goes over a certain threshold. Then we'll put all of our queries, our alerts, and our dashboard into a workflow to orchestrate our pipeline. And lastly, we'll analyze the lineage diagram that showcases the flow of our data from its origin. Once you're logged in, Databricks presents a landing page with unified navigation. In the navigation bar on the left, you'll see a section titled SQL. Here, you can see the tools to create a query, view dashboards, explore data, or even connect to a BI tool. SQL warehouses are the compute resources that let you run SQL commands on data objects within Databricks SQL. Let's go ahead and create one. Please know that you may or may not have warehouse configuration permissions in this training because you may not have the right privileges. So to create a SQL warehouse, you're going to give it a name. Then you're going to give it a cluster size. For this training, we'll choose an extra small cluster size to keep the cost down. To reduce the latency of queries, you can increase the size. Larger sized clusters have a larger coordinator and doubles the number of cluster workers. We have auto stop, whether the warehouse stops if it's idle for the specified number of minutes. The scaling piece here is for horizontal scaling. Typically, a cluster will be able to auto-scale up and down to handle concurrency horizontally. We'll choose our warehouse type, in this case serverless. This will run our SQL and BI workloads on a fully managed secure compute environment that starts and scales up and down within seconds. Tags allow you to easily monitor the cost of cloud resources used by various groups in your organization. Unity Catalog allows you to administer data access policies that apply across all workspaces and personas, and admins can grant permissions at the level of catalogs, databases, tables, and views. In this case, we're making sure that our warehouse is Unity Catalog enabled. Let's click Save and start up this warehouse. Now for warehouse permissions. With SQL Warehouse Access Control, individual permissions determine a user's ability. There are 4 permission levels for a SQL warehouse. No permissions, obviously, can monitor, can use, and can manage. In the Connection Details tab, this is where you can get details to connect Databricks to your data ingestion tools and other JDBC connections as well. You can also use Partner Connect to use other ingestion tools that you might be familiar with. So Partner Connect lets you select Databricks technology partners and connect your Databricks workspace to partner solutions from the Databricks UI. And if you have the right permissions, you can also monitor your warehouse. You can examine the number of queries handled by the warehouse and the number of clusters allocated to the warehouse. When executing a query, you can always navigate back to the SQL Warehouse Monitoring tab to understand the runtime statistics. Up until this point, you've seen and understood how SQL warehouses work. Now, let's ingest some data and then explore it. The Catalog Explorer provides a space to explore and manage catalogs, schemas also known as databases, tables, and permissions. The Catalog Explorer is the main UI for the Unity Catalog object model. The first thing we're going to do is create a catalog. A catalog is the first layer of the Unity catalog hierarchy, and it's used to organize your schemas. You can create a catalog through the Catalog Explorer or a SQL command. To create via the Catalog Explorer, just click the Create Catalog button and then give your catalog a name. The catalog type can be set as standard or foreign. Standard would be a catalog for where your data is in your respective cloud storage, and foreign would be a catalog where you could have a connection to an external database such as MySQL, Postgres, Snowflake, etc. And for this workshop, we'll stick to standard for ease. Next, you'll create a schema, aka a database. It's the second layer of the object hierarchy, and it contains tables and views. Navigate to your newly created catalog and create a schema, and give the schema a name. You'll now see your new schema in the catalog. Permissions can be added at the catalog, schema, and table level. At the catalog level, you can grant or revoke permissions by going to the Permissions tab. When we grant a new permission, you can select a user or a group and different permissions to give. Similarly, permissions can be added at the more granular schema level. Now that our catalog and schemas have been created, we can now create tables by writing SQL queries. The SQL editor allows you to query data, view data in the schema browser, build visualizations, and configure alerts. Here, you can browse your schemas and tables and begin creating tables and writing queries. In this example, we'll be following the Medallion Lakehouse architecture. The Medallion architecture is a data design pattern to organize data in a lakehouse. The goal is to progressively improve the quality and structure of the data as it flows through each layer. Bronze is our raw, unvalidated data, silver is the clean and conformed data, and then gold is our curated business level tables. First, we'll create our bronze streaming tables. You can create streaming tables which are designed to handle each row only once as you process a growing data set with support for streaming or incremental data processing. Here, our first streaming table is our customers_ingest. We are reading sample data from the Databricks file system, but in practice, this path can be replaced with your Cloud Object Store path. There are different options you can set for format options and copy options to control the operation. My query has already been ran, but please run your query to view the results. Make sure you give each query an identifying name, and make sure you save the query after any changes have been made. Now we can ingest the remaining tables, line item, and orders using the same syntax. Here's our line item query, and we're creating or refreshing our streaming table that will title line_item_ingest. And lastly, we'll ingest our final bronze table, which is our orders_ingest. To view the new tables, just head to the Catalog Explorer. Please be reminded that these streaming tables is our initial bronze layer. The bronze layer is a raw data set that retains the full on-process history of each data set. If we click on a table in the Catalog Explorer, we can see more information about the columns, we can preview some sample data, view details about the table, and we can view and create permissions. We can see history and even lineage, which we'll touch on at the end of this training. In the Overview tab, you can see the schema of the table. This provides the user the structure of the data object, including the data types. In the Sample Data tab, it provides a visual view of the data stored in the table. This can tell you if the table contains any complex data type, such as nested columns, and you'll be able to view them here. Clicking the Details tab, you can view the location of the table files, the type of table, and table properties. And lastly, you can click on the Permissions tab. Here, a data owner or administrator can grant or revoke permissions and privileges for this table. Now, we're going to create our silver tables using materialized views. Silver tables represent a validated, enriched version of the data. And we'll use the Create Materialized Views statement to update existing tables when changes are made. So in this case, we're creating orders MV materialized view. And we're leveraging our orders ingest bronze table. We want no null values and we want a certain date. Don't forget to run and save your query. Now, you'll create a materialized view for your customers. We'll call this one customers_MV. And again, we're creating this materialized view from our bronze ingest table called customer ingest. Similarly, we don't want any null values, and we don't want the key to be equal to 21. Lastly, we're going to create our silver materialized view for the line item table. We're using the same kind of syntax, however, we're titling it line item MV. Now, let's create a gold table. These tables are refined and aggregated data tables. To do this, I'm actually going to leverage the Databricks Assistant. The Databricks Assistant is great because it is a context-aware AI assistant available natively in Databricks notebooks, the SQL editor, which we're here in, and the file editor. Databricks Assistant, it helps you query data through a conversational interface, making you more productive inside of Databricks. The Databricks Assistant can not only create a query, as I'm doing here, but it can also explain code and actually also fix errors if you have any. We can verify that our gold table has been created by running a select statement here. Now we're going to focus on data modeling. To simplify SQL operations and support migrations from on-prem and alternative warehouses, Databricks Lakehouse gives you the ability to build entity relationship diagrams that are simple to maintain and evolve. These features allow support for defining primary keys and defining foreign key constraints. Defining primary keys and foreign keys helps BI analysts understand the entity relationships and how to join tables. So the first thing we're going to do is we're going to alter the customer silver table. This is a table that I created from the customers MV, and it's the exact same table. However, it's not a materialized view. And this is because materialized views do not support identity columns or surrogate keys. I'm going to alter the column customer key as not null, and this is because the column must have unique values. Then I'll create the primary key. Now for the foreign key. I'll add my foreign key to my order silver table by referencing my customer silver table using the code below. Don't forget to drop the null values by running this code below. Now I'm going to define the foreign key and now validate that the primary key was created by heading over to the Catalog Explorer tab and finding our table. As you can see, the primary key has been defined and the key icon is beside the column Custom Key. We can also validate that our foreign key was created as well. Databricks provides a clear and intuitive representation of how data entities connect with the entity relationship diagram, and you can view it here under the table with our foreign key. Now we're going to navigate to the query history and profile. The query history shows SQL queries performed against SQL warehouses, and you can use this information here to help debug and optimize your queries. If you click on a particular query, you'll see the query details. This will include information such as the query's duration, the SQL command, number of rows returned, and even the I/O performance. If you click on See Query Profile, this will take you to a more detailed view of the query's performance, including its execution plan. To create dashboards in Databricks, it's even easier with the introduction of AI BI dashboards. Let's go ahead and just get started. First, you're going to click Dashboards and then click Create Dashboard. For this workshop, we'll add our data as a table and add the orders underscore MV, which is our materialized view. Awesome. Back in the canvas, to make a visualization, just click the chart button in the blue bar at the bottom. Here, we can drag and drop our chart area, and we can immediately take advantage of the text-to-viz feature. Databricks SQL provides BI analysts to create visualizations seamlessly. With these capabilities, you can create visualizations using natural language, and this can be helpful for technical or non-technical users who'd like to derive insights from their data sets. In the prompt, you can type virtually anything to get started, but for the purposes of this workshop, let's keep it simple. Let's do order date versus total price. So we have a general skeleton of what we want our data to look like, but we can make it even better by editing it to our needs. Hit accept so that the AI model can remember this visualization for next time. Here is a finished copy of the dashboard. Let's go ahead and add a filter. Filters can be great when needing insight quickly, and AI BI dashboards thankfully support various filter types. Let's create a filter that filters the dashboard based on a specific customer ID. And there you have it. All new AI BI dashboards, they begin as a draft. You can share these drafts with others in your workspace, and you can collaborate with each other. Click the Share button in the upper right corner. Then a familiar menu will appear where you can search for a user to share with and give that person permission to manage, edit, run, or just view the dashboard. AI BI dashboards can be published to make a clean copy of the dashboard that you can share with users within and outside of your Databricks workspace. Here, you're given options around embedding credentials. Embedding credentials as a default means that all viewers of the dashboard can run queries using your credentials and compute. This will allow users to see the dashboard even if they don't have access to the data or SQL Warehouse. However, this may expose data to users that haven't been granted access to it. This option must be selected if sharing with users without access to your Databricks workspace. The Don't Embed Credentials option means that all viewers of the dashboard run queries using their own data and their own compute credentials. For this, viewers will need access to the workspace, access to the attached SQL Warehouse, and the associated data to view the dashboard. For purposes of this training and workshop, we'll keep the embed credentials for this. Let's publish it. And with this published chart, users that have permissions are able to select the filter to view the chart based on the different customer IDs. Databricks Genie Spaces enables business users to interact with data on LLM-powered question and answers. End users can ask questions in natural language and receive answers in text and visualizations. This curates dataset-specific experiences with custom instructions powered by Databricks SQL and Databricks IQ. To go to the Genie Spaces, head back to the Catalog Explorer, select your catalog, then your schema of choice, and then your table or materialized view. Then click the Create button, and you'll see the option for Genie. When you click on it, it will require you to input some basic information of your new space. Please note that you need to select a running SQL Warehouse, and it has to be serverless so that Genie can use it to process your questions and provide answers accordingly. We already have our catalog, schema, and table or materialized view selected. However, you can go ahead and add more if you'd like. Then add a sample question, such as, show me the customer table data, so it can appear as a default question. Once you hit save, you can now see your orders analysis workspace created, and that sample question that you created is also present. Go ahead and click on it, and it should display all the data in your orders materialized view. Click the Show Generated Code, and it will show the SQL code used to get the data from the table. This means users could ask questions in plain English, and Databricks LLM-powered processing engine will provide answers. And it will also show the code used to generate these results. This dramatically lowers the bar for generating quick insights for both data workers and business users. You can keep interacting with Genie in the workspace by asking more questions. For example, show me the orders by status. You'll be provided with the results based on this question. And you can also like or dislike the answer by clicking the thumbs up or thumbs down button at the bottom right corner. This again will help the LLM to auto-tune and give you better results next time. Once you're happy with the results, clicking the Auto Visualize, which is one of the quick actions, will create a sample visualization of the orders data. This chart looks good. It's not bad, but what if you want it to look nicer? So you can type in, could you change the color for each category? And here's what you get, making it much easier to read. You can be as creative and as free to interact with Genie by simplifying it and asking more questions for your data. Databricks goes a step further with monitoring. You can also check out all the previous conversations in the same Genie space. You can understand the errors, feedback, and the results the space is returning for your users. Click on the Go to Conversation button if you wish to continue a previous conversation, and this will navigate to the chat screen. For example, you can now ask, "Show me the above data in a pie chart, please." And this will provide data visualization in a pie chart format. The good thing is, in Genie, it remembers your previous context and conversation. With this, users can easily go back to the last conversation and continue their work without worrying about starting from the very beginning. Again, keep asking questions with Genie. It's super easy to use, very powerful to generate quick and valuable insights on your enterprise data, specifically to answer the questions that you care about without having to run any code. Next, let's configure alerts and understand user settings surrounding these alerts. Alerts can be used to set up to notify you when a field returned by a scheduled query meets a certain threshold. To do so, just head to the Alerts tab on the left-hand side. Click the Create Alert button in the right corner. You can give the alert a name and then select the query that you want the alert to be based on. For example, I can base my alert on the orders table. We'll set up an alert for when the total number of orders goes above 800,000. You can also set up notifications of how frequently you would like to be notified. And then you can also create a template. There's also an ability to set up a refresh schedule. And then different destinations can be added for the alert as well. Databricks Workflows is a fully managed orchestration service. It enables data engineers, data scientists, and analysts to build reliable data, analytics, and ML workflows without the need to manage complex infrastructure. The goal here is to make a workflow that takes the raw bronze data and transforms it into our final gold table and refreshes the dashboard. As you can see, this workflow does exactly that. The line item bronze and orders bronze tables are cleaned to create the line item silver and order silver tables. And then those silver tables are joined to create the order status gold tables. And then an alert. Lastly, there's a task here to refresh the dashboard. Now, let's talk about Lineage. So back in the Catalog Explorer, we can view lineage graphs for each table to see all the upstream and downstream tables. To view the lineage diagram for a table, for example, the order silver table, click on the table and then go to the Lineage tab. Here, we can see the upstream, downstream tables and a list of workflows, dashboards, and queries that the table is used in. If you click on See Lineage Graph, you can now get a graph and a depiction of the upstream and downstream tables. Now, this concludes this training. I hope that you enjoyed it and that you feel encouraged and empowered to get started using Databricks SQL for all of your analytics, your warehousing, and BI needs.